welcome to the AI with Arun show. Look at this image that you see on the screen. It speaks of exploration, of stepping into a new frontier. This is the perfect metaphor for what we are here to talk about today. A groundbreaking technology from Google called Genie 3, which was launched on August 5th, 2025. You've probably heard about AI that can create images or write text from a simple prompt. But what if you could prompt an entire interactive world into existence? A world that you cannot just see but play in. That is the dawn of the neural game engine, and Genie 3 is at the forefront of this revolution. In this episode, we'll explore what Genie is, how it represents a monumental leap forward, and what it means for the future of AI, robotics, and even the games that we play. To understand why Genie is so special, we first need to understand the landscape. For the past year, the world has been amazed by AI models like OpenAI's Sora and Google's own Veo. Now, these are incredible tools that can create stunning, high fidelity video clips from text, but they create passive videos. You can describe a scene and the AI will generate it, but you cannot interact with it. It's like watching a movie. Genie 3 is something fundamentally different. It's a world model. It does not just generate a pre made clip, it generates each new frame on the fly in real time based on your actions. You're not watching the movie, you are the main character. This requires the AI to understand cause and effect and to respond to your commands instantly, making it a substantially harder technical challenge. And Google has been tackling this challenge at an incredible pace. Just think about this timeline. In February 2024, we saw the first version, Genie 1. It was a proof of concept, an 11 billion parameter model trained on over 200,000 hours of 2D platformer games. It was amazing, but it was limited to 2D and could only generate one frame per second. By December 2024, Genie 2 made the leap to 3D worlds generated from images. The quality improved, but it still was not interactive in real time. You would give a command and you would have to wait for it to process. Now, in August 2025, we have Genie 3. It generates 3D worlds from text prompts at 720p resolution and crucially at 24 frames per second. This is real time fluid interactivity that can remain stable for several minutes. The speed of this revolution from a slow 2D model to a real-time 3D world simulator is about 18 months, shows just how focused Google is on this technology. So how does it work? Let's look under the hood at its core architecture. It stands on three main pillars. First is auto-regressive frame generation. Think of it like a flip book. Each new page or frame that the AI draws is based on all the previous pages and all the actions that the user has taken. It's constantly telling a visual story that builds on itself. Second, it has advanced dynamics model. This gives Genie an intuitive understanding of physics. It has not even been explicitly programmed with physics equations, but by watching massive amounts of video, it has learned that water should flow and light should shift in a believable manner. Finally, and perhaps the most mind-bending, is emergent consistency. The worlds Genie creates don't have a traditional 3D geometric skeleton holding them together. The consistency, the fact that objects stay where they should and the world feels solid, emerges as a natural result of its massive scale training. It has seen so many examples of what a world should look like that it can create a coherent one on its own. Now, these pillars support three key innovations that truly set Genie 3 apart. The first and the most important is real-time interactivity. Running at 24 frames per second, it feels fluid. This transforms it from a technical curiosity into what we can truly call a neural game engine. Second is visual memory. The worlds have a sense of permanence because the model remembers changes to the environment for a minute or longer. If you push a box, it stays pushed. And third is promptable world events. This is where it feels like you are a director, not just a player. Mid-session, you can use text prompts to change the world around you. You can make it start to rain or suddenly add forest of glowing mushrooms. Now, these features together are what defines this new frontier for generative AI. But here is the most important thing to understand. Google's primary motivation for building Genie 3 probably is not to revolutionize the gaming industry. It's a cornerstone of their mission to create artificial general intelligence, or AGI. It's based on a philosophy called the world as simulator doctrine. The idea is simple but profound. To build a truly general intelligence, an AI needs to learn the same way as we do by interacting with an environment. It needs to be able to perform an action, see the consequence, and build its own internal understanding of how the world works. This is a bet that true understanding does not come from just reading all the text and seeing all the images on the internet, but that the ability to act as a prerequisite for deep understanding. This makes Genie 3's primary application clear. It's a training ground for other AI agents. It solves a huge problem in robotics, which is data scarcity. Training a robot in the real world is incredibly slow, it's expensive, and it can be dangerous. Genie 3 offers a solution: unlimited simulation. It can generate an infinite variety of safe, scalable environments for AI agents to learn in. An AI agent can fail a million times without any real world cost or consequence. The ultimate goal is what is called sim to real transfer, making the simulated worlds so realistic that the lessons an AI learns inside Genie can be transferred to a physical robot in the real world. And Google is already doing this, linking Genie 3 with its SEMA agent, creating a powerful loop where the AI can practice, learn, and improve. So, where does Genie 3 fit in the competitive landscape? As we can see, the field is really splitting into two main directions. On one side, you have models focused on content generation. This includes OpenAI's Sora and Google's Veo. Their goal is to create beautiful, passive video clips for media and creative applications. On the other side, you have models focused on agentic simulation. This is where Genie 3 sits. Its core function is real-time user control with the primary goal of training embodied AI agents on the path to AGI. It's fundamentally different from a physics-based simulator like NVIDIA's Isaac Lab, which is programmed with explicit rules, whereas Genie's understanding is learned. While the grand goal of is AGI, the practical applications in the near future are revolutionary, especially for robotics. Imagine the industrial applications, creating a perfect digital twin of a factory floor or a warehouse, allowing a robot to train for its job in a virtual replica before even being deployed. Or consider high stakes training. We could simulate dangerous scenarios for emergency responders, letting them practice in hazardous situations like a chemical spill or a burning building without any real world risk. Overall, this allows for accelerated development. Engineers can rapidly test and iterate on robotic behaviors in a safe and cost effective virtual world, dramatically speeding up the development process. And of course, we have to talk about gaming. First, there is a potential for economic disruption. We all know that modern AAA game development has become incredibly expensive, with budgets soaring into the hundreds of millions of dollars. A tool like Genie 3 could drastically reduce the time and cost of creating massive, detailed game environments. This leads to democratized development. By lowering the technical barriers, Genie 3 would empower small studios or even single creators to build games with a scope and scale that was previously only possible for giant corporations. Realistically, the near term impact will be its integration into existing workflows, serving as an amazing tool for rapid prototyping and asset creation. And make no mistakes, this is a huge market. The AI in gaming sector is projected from under $6 billion in 2024 to nearly 38 billion by 2034, driven precisely by this need for more efficient content creation. The potential of this technology extends far beyond gaming and robotics. Think also interactive education. Instead of just reading about ancient history, a student could walk through a dynamic construction or a reconstruction of the Roman Forum. Instead of a flat diagram, they could navigate a virtual ecosystem to understand how it works. Or consider creative prototyping. A filmmaker or an animator could instantly generate and explore a virtual set. An architect could create a virtual walkthrough of a building for a client, all without needing deep expertise in 3D modeling. In every case, the paradigm shifts from passive learning to active exploration, offering a much deeper and more intuitive level of understanding. Now it's important to be realistic. As incredible as Genie 3 is, it's still very early technology and faces significant challenges. First, duration limits. The ability to maintain a stable world for several minutes is a breakthrough, but it's not nearly long enough for a full game or a complex training simulation. Second, physics fidelity. While its intuitive physics are impressive, they are imperfect. The model can still exhibit strange artifacts or fail at basic physics tasks. Third, it is single agent only. Right now, there are single player experiences. The system struggles with the complex interactions that would be required for multiple independent agents. And finally, the computational cost. Consider a 720p world at 24 frames per second in real time that requires an immense amount of computational power, raising serious questions about the economic viability and environmental impact of running this at scale. But beyond the technical challenges, this technology forces us to confront some profound ethical and societal questions. First, labor and creativity. What does a tool that can generate entire world means for the careers of creative professionals in gaming and animation? It also raises very difficult questions about copyright and authorship. Second, governance and misuse. We worry about deep fakes, but this technology enables deep realities, fully interactive, simulated worlds that could be a powerful and dangerous new form of misinformation. Who decides what can and cannot be generated? Third, the psychological impact. What are the societal consequences of infinitely engaging personalized virtual worlds? This raises serious questions about technology addiction and the blurring of lines between reality and simulation. And finally, the environmental footprint. We cannot ignore that training and running these massive models requires staggering amounts of electricity and water, posing a significant sustainability challenge. So, what's the road ahead? Given the quantum leap we have seen from Genie 1 to Genie 3, we can expect future versions to focus on tackling the current limitations. That means extending the interaction time from minutes to hours, improving the physics and logic engines, enabling multi agent simulations for multiplayer experiences, and boosting the resolution for full VR and AR integration. But the ultimate goal remains the same: to create a seamless, infinitely variable simulator, a metaverse generated on demand, to serve as the ultimate training curriculum for the development of AGI. Genie 3 is truly a landmark achievement. It stands at the intersection of immense promise and significant peril, and it forces us to fundamentally rethink what's possible in content creation, AI training, and the very nature of our digital lives. With that, we come to the end of the show. Thank you for watching. Like, share, subscribe, and support our work by joining us as a member.